All right, so today I will be going over some more math topics, ACT related math topics connected to geometry. So these are going to have maybe diagrams and maybe we find an area or perimeter or something like that. So this is all going to be like ACT style questions where you have to use some geometry to get to your solutions. All right, so I hope you had that diagram drawn out. I'm going to ask one question about it. It was like 3 questions connected to that diagram, but I'm going to focus on one of them. And that is, what is the perimeter in feet of the park? So we're putting a fence around their park, and they want to know, okay, how much fence would you need to buy to surround their park? All right, so basically, we got to understand how to find perimeter. What I was told at a very young age is to find the perimeter, you add up all the sides. That's it. So even when I got to high school and they gave me all these formulas, all I knew was you add up all the sides. So basically, that's how you find perimeter. This problem is going to be more involved, though. It's not going to be as straightforward as that definition. But if we understand that's all you need to do, that's what points you in the right direction. Since I'm only focused on the perimeter, I'm only really paying attention to the exterior of the diagram. I don't care what's on the inside of it. I know the diagram had like other things drawn into it. That doesn't matter for the perimeter. So I only put down the numbers that I know I need to focus on. And this is pretty much what we have to work with. For me to find a perimeter, all I need is that missing side, and then I can add all the sides up. So this is how we start to dissect this problem. So the first thing I do is I have to make a imaginary cut right there. And I know that this whole bottom side is 40 inches. But notice how right here I have a 28, then over here I have a 12, because 28 and 12 is 40. I know this part is 28 because it's directly across from that part, which is also 28. So I at least know that these are the same length. And that allowed me to break it into 28 and 12. I know that this is 16 because that's 16. If that comes all the way over here, it's still 16 inches. So it allows me to break this into, instead of one trapezoid, right? Instead of one trapezoid, I'm now breaking into 2 shapes, a rectangle and a triangle. Now let's focus on this triangle. Notice how I just made a mark here. That's a hypotenuse now. I have a right triangle, I have a hypotenuse, I have 2 legs. All day long, that is Pythagorean theorem. Now, peep how this started off as a perimeter problem with a trapezoid. As you dissect the problem, is now a rectangle plus a triangle. And so we can leave from the perimeter for the moment and go into a Pythagorean theorem, because that's the only way we're going to figure out the hypotenuse length. All right, so a squared plus b squared is equal to c squared. 12 squared plus 16 squared is equal to hypotenuse squared. All right. 12 times 12 is 144. 16 times 16 is 256. Is equal to hypotenuse squared. If I add these up, I get 400 hypotenuse squared. Square root both sides. Now I'm looking at 20 is equal to my hypotenuse. Now that means this is no longer an unknown value. This is 20 inches now. Now I know what all of my sides are, and I can do my perimeter. All right, so basically I just added up everything. Just to kind of explain what I just did here, I know some people add a little different, but I start off by adding using place value. So that's 40, 60, 80, 90. That's where the 90 came from. Then I looked at the 8 and 6 and said 14. So I did a 90 on the front, 14 on the back, and then that's 104. So that's why I did it like that. All right, I know that's a little different from some people, but I use my place value when I add. So this is what it was asking. What is the perimeter in feet? What is the perimeter in feet? If you picked answer C, which is 104, you have picked the incorrect answer. So just to give you a little encouragement, if you did get 104, right, that means you do know how to do the mathematics. Get what I'm saying? So if you got 104 and you picked it, that doesn't mean you don't know the mathematics. You still know the mathematics. But remember, this is an ACT test. So it is testing you on not only your mathematical skills, but it's trying to see if you're thinking, reading, and comprehending. So you getting the math right, but the comprehension of the question is still important. And I'm going to point out one thing that I didn't talk about on purpose, but it is in the picture when you read the question. This was a key thing in there. It tells us that 1 inch is equal to 1.5 feet, right? So when we get 104 inches, we have to do a unit conversion based off of these two numbers. So if I have 104 inches, then down here I have to use 1 inch to my 1.5 feet. That's why my inches get to cancel. And now whatever I multiply straight across, it leaves me in feet. The true answer is 156 feet. D. The true answer, not D, E, excuse me. So what started as just a perimeter problem ended up being Pythagorean theorem and a unit conversion. So when you're doing problems and you know you have missing information, something previous is probably what's going to get you there. It's going to be some previous knowledge or something else outside of what they're directly asking you for that'll get you your missing information just so that you can come back to answer the question that's at hand. So always make sure that you pay attention to the question, especially with diagrams, with measurements and stuff. If they're asking you for something in feet, make sure that what you're working with is in feet. If it's not, you know it's going to require some type of conversion.